introduction?
I came by Richard at the FARS banquet a couple years ago, and I believe it was the KPH radio station presentation. I thought it was fabulous, so I contacted him to see if he'd do it here, and then he told me, "Well, I have another topic that might be of interest. What do you think?" And I said, "Oh, okay, sure." Twist my arm. So it just looks fabulous. Great presenter, and so let me turn it over to Richard, and it's all yours. Thanks for being here, my friend.
Well, thank you so much, Rob. It's a real pleasure to meet everyone and an honor to be called back for an encore performance. I take that as a high compliment indeed. And yes, the original presentation was on KPH, which is the station, the Morse code ship-to-shore station that we have restored to operations. So I heard about your field trip to the Hornet, and if I'm not sure whether the group has made a field trip to KPH, but if not, or even if so, if you wanted to come first time or again, we'd be happy to arrange that. Please contact me so we can make sure we give you the absolute A tour, and that could include the transmitter site and the receive site, or just one, or whatever it is you would like. The presentation this evening, as Rob mentioned, is about the other aspect of what took place at the transmitter site that we now use for KPH. And that began in 1914 as Marconi's original business plan, part of his business plan, which was to undercut the folks that had a monopoly on intercontinental communications at the time. And of course, that was the undersea cables. And if you wanted to send a telegram to Hong Kong or across the Atlantic to Europe, you had to pay their price, which they set because there just was no alternative. And this station that was built here near where I'm sitting now was the Pacific link in that worldwide chain. But of course, that had its roots long before the station was actually built here. And the reason is that, of course, nobody knew really what was going on with this radio and wireless business. There were a lot of folks who were experimenting in the field, scientists and engineers, including Heinrich Hertz, who we see here. And of course, Hertz is now had his name attached to cycles per second, as we used to call them. And he did experiments in his lab that let him know that something was up that he knew nothing about, nobody knew anything about. But his experiments showed that if he had a spark coil on one side of the room and generated a spark across it, an induction coil, on the other side of the room with just a loop of copper with a couple of balls on the end of it, when the spark jumped across the spark gap at the induction coil, he could see a spark jump across the balls between the two balls on the little loop of copper. Now, this is a bit of an exaggerated drawing because the spacing between the two balls on the loop that he was holding was only the width of maybe a couple of paper widths wide. And he actually had to turn off the light in the room to see it. But nevertheless, he did. So what's happening here? Nobody explained it. This was entirely new. The thing is that he and the other researchers in the field really looked at this as a laboratory curiosity, perhaps an interesting physics problem, but never crossed their minds that it would be anything more than that. So when people say, who invented radio, excuse me, and everybody says Marconi, well, of course, that really isn't true. We know that's not exactly the case. But he did have a real contribution. I'm just going to turn off the mic here for a second so I don't burden you with another cough there. And his genius, he didn't invent radio, but he did bring together these laboratory curiosities, this work that was done by other workers, and he was also always very good at acknowledging that his work was built on the shoulders of others. Now, he himself made some significant fundamental inventions and additions to the field, but he always acknowledged that his work was based on previous work by others. And his idea there started to really coalesce in his mind that maybe there was something more to this. And if he wasn't the inventor of radio, I think it's fair to say he was the inventor of radio as something that could be a useful and even commercial enterprise. Nobody was really thinking of that at the time. This is some of his early apparatus, and we see the transmitter on one side. By that, it was a spark transmitter, of course, and he had it in a box because these things are pretty noisy, as folks may know. And then the receiver over on the other side. By our view today, this is very primitive stuff. In those days, it was cutting edge. This was the bleeding edge of technology. He was lucky enough to have wealthy parents. Here he is experimenting on his father's estate in Italy, in Bologna, and he was starting to get distances that seemed to perplex him, because all the engineers, all the scientists of the time were saying, hey, what's the matter with you? A nice Italian boy, you could be driving a truck. Why are you messing around with this stuff? And they're all telling him, everybody knows that radio waves don't go over the horizon. So listen, there's nothing to this. There's no future in it. And that's what his father said too. His father refused to support his work because he thought it was nonsense. And Marconi, he knew how to hold a grudge, and to the extent that because of his father's failure to support him in his work, when his father finally died, he didn't go to the funeral. So the man knew how to hold a grudge. Now, normally that would have been the end of it, but Marconi's mother was not Italian. Here she is, as you can see, a formidable woman. She was not Italian. She was Irish, and she was the heir to the Jameson whiskey fortune. So she had funds of her own, very unusual for the time. And she did believe in her son. She did believe in him. And she was willing to spend her fortune in helping him to achieve his goals. She said, my son, I love you so much. I believe in you. Here's my credit card. Go down to HRO, get whatever you need. And of course, there was no HRO. There was no credit cards. There was no nothing. Everything was being invented from scratch, step by step. But if it wasn't for her help, that would have been the end of Marconi's efforts right there. Well, we're going to jump ahead quite a ways now, because he kept on getting longer and longer ranges, a mile, 10 miles, 100 miles across the English Channel, 21 miles. And even though that's a relatively small distance, the symbolic nature of leaping over the English Channel was big. So 100 miles, 1,000 miles, why not 3,000 miles? Why not across the Atlantic? Why not establish a link between Europe and America by wireless? So he built this station at Poldhu on the western shore of the United Kingdom of England. And as you see, the antenna, now, of course, the transmitter was a spark transmitter. That's the only technology really that anyone had to generate radio waves at the time. And this one was by far the biggest and most powerful one ever built to date. And here's the antenna. Now, you were talking about having an antenna party earlier. Anybody who looks at this and sees how it's built with triadics holding everything together, and on the storm-tossed west coast of England, well, what do you think is going to happen to this in the first storm? And yes, you're right. This is what happened. So why they thought anything else would happen, that's a mystery. But they quickly rebuilt the antenna here with a different structure. It's 4 wooden lattice towers with a cone-shaped antenna that came down to the transmitter building. And on the receive side, on the opposite side of the Atlantic, they had a similar antenna set up. And of course, the same thing happened to it. So here's Marconi. He has bet And this is the first time of many times that he bet his reputation and his fortune and his company on his dream. He said, yes, I can do this. We can get this wireless signal across the Atlantic, and this will be a milestone and a moneymaker for us. But now he's got the transmitter going again, but the receiver, he's got nothing compared to what he was planning to have. So they're thinking, what are they going to do? And here's Marconi in St. John's, Newfoundland. In December, my friends, I have been in Newfoundland in December, and I can tell you, it is no picnic. But there they are anyway. They are on the top of what is now called Signal Hill. It may even have been called that then, in this freezing little house, that stone house that's up there. And on the right side is George Kemp, Marconi's long-suffering assistant. And I don't know who the person is on the left, another assistant, and of course, Marconi in the middle of it all. Now, it's significant that they are sitting, or Marconi is sitting, and George Kemp are sitting on a wicker basket. Notice that they're sitting on a wicker basket. And behind them, it may not be apparent, but it will be in the next photo, that they have a kite, a giant kite behind them. And Marconi was known, so the accounts say, as an expert kite flyer. Well, okay, I'm willing to believe that. So in the wicker basket is not only the kites, but a balloon. That was their first idea. They're going to inflate a balloon with hydrogen gas and send an antenna up, a single wire antenna up into the air, supported by this balloon. So they do that, and they go out there. I remember December in Newfoundland, wind is blowing like mad. So they send the thing up there, and of course the wire breaks. The balloon disappears downwind, never to be seen again. Wire flops down on the ground. They reel everything in. So then now it's time for the kite. So here's the kite outside that little stone or cement building, and they're getting this thing aloft. And as you can see, it's just a real task. But they do it. They get it up. They get this thing up there, and it's tossing back and forth in the sky, and they have the single wire antenna coming down to the receiving apparatus in this little building here. And here it is. I mean, check it out. There's not a lot there. By our lights, it's, really hard to believe that this would do much of anything. Now, in those days, it was not typical to actually listen by ear to wireless signals. They were printed on inked tape. That is to say, you had this apparatus, maybe you've seen them. They were common in old central fire alarm stations. So as the dots and dashes came in, the apparatus, the spring wound apparatus, would record the dots and dashes on the paper tape. And that was used to read. Then you would read the dots and dashes and get your message. The other advantage of this, especially in a situation like the one Marconi was in, is that you could prove that you actually got the signal, as you actually had the printed evidence of it. So there they are, sitting there freezing in this little room, and nothing. Paul Dew is sending the famous 3 dots, S, ... continuously. That was the order. Just keep sending. So they're throwing into the sky this enormous energy from this giant spark transmitter through this enormous antenna, and hoping that it's going to get across the Atlantic. So they're sending it ... and they're getting nothing. Zilch. Nothing is happening. So Marconi then took this step. Oh, by the way, this is the receiving apparatus. It's known as a coherer, and you may have heard of these. So to us these days, we would look at this and say, well, it's impossible. I don't see how this thing would work at all. And if it did, it would be about as sensitive to radio waves as a brick. So here's a schematic, or a drawing, not really a schematic, a drawing of what a coherer looks like. The P's indicate plugs, usually brass, and it's inside this evacuated glass chamber with nickel filings. Sometimes people would use all different kinds of combinations of metals for these filings between the two plugs. And when a strong enough radio signal, wireless signal, was impressed across the coherer, the resistance would drop dramatically because the particles would cohere. That's the name. And that would run the circuit and the printer, and you'd make your dash on the tape. The problem was that the coherer, when the radio signal stopped, the coherer, the particles in the coherer did not decohere. So once they were in a conductive state, they were there permanently unless you tapped the coherer. So there was an arrangement that automatically did that. So it would follow the dots and dashes. This is a coherer that I have, and it's, of course, not an original one. Those are very rare and expensive, but a colleague makes these for experimenters to use. So that's what the thing actually looks like. So, okay, they're getting nothing. They're sitting there, and there's just, all they can hear is the wind howling outside and the kite flapping back and forth. So Marconi used this highly modified earphone. You see the horseshoe magnet and the coils on the horseshoe magnet. We're not really sure how this was supposed to work, at least I'm not. But he transferred from the idea of waiting for the dots and dashes to appear on the tape to hearing it by ear. So now picture this. There they are up there, December, Newfoundland, on the top of a hill overlooking the gales of the Atlantic. And Marconi holds this thing up to his ear, and he says, "Mr. Kemp, do you hear anything?" And he hands the earphone over to George Kemp. Now, put yourself in the position of Mr. Kemp. There he is, freezing his butt off. All he's thinking about is getting back down to the pub before the fire, having a hot meal, and getting into bed. Now, what would you do in that situation? And of course, George Kemp says, "Yes, yes, I hear it. I hear the three dots. Yes, I hear it." Well, you can start a fight in a radioman's bar to this day by claiming that Marconi did or did not hear those three S's on that December day in Newfoundland. But you know, it really doesn't make any difference, because not more than a few years later, he had already started to establish his global network of stations around the world, linking the continents by wireless. And this, again, he bet his reputation, he bet his fortune, he bet his company on the promise that he could do that. This is the earliest diagram of his network that I was able to find, and it shows the San Francisco station, the one that we're going to be talking about. So this is actually in operation. He showed it could be done, and he undercut the tariffs of the undersea cable operators by 50%, and was still able to make a big profit. And of course, they say, "Well, you can't do that. We have a monopoly." He says, "Well, sue me." And nothing came of it. So he had a commercial operation going. Now, here is the land in Bolinas, California, Marin County, where I live, just south of me, where I'm sitting, and overlooking the Pacific, just north of the Golden Gate. And here is a ranch that's there. And here is some surveyors, and they're checking it out because this is where they want to build a transmitting station in Bolinas. Now, you see this notebook here. I couldn't believe it. You know, there's a colleague, a local historian, beloved guy, really, really knowledgeable and good, and he's in charge of the special maps room over at the county. So I went over to visit him, and he had some wonderful maps of the site and things, but he also has the surveyors' notebooks of the surveyors who made the readings and took the angles to decide where they were going to put the station. And I choose to believe that the notebook that I actually laid hands on is the one in this guy's back pocket. Well, here is essentially the same shot showing the station having been built. And you see out there the coast and the ocean beyond. And here is the building. They called this the powerhouse. These days, we think of a powerhouse as an electrical generating plant. In those days, that was the term that was used for a transmitter building. And it really was a powerhouse. You'll see some of the stuff that it took to generate a high power signal using spark technology back then. So you get the idea. Here we're standing on what, or we're seeing below, I guess, what is Mesa Road. That is still the road today that we use to get out to the station. And now keep in mind that all this equipment had to be brought around the Horn, right? No Panama Canal, around the Horn by a clipper ship into San Francisco, where it was transferred to schooners that came across the Golden Gate and landed the equipment here on the wharf in Bolinas. And they had to strengthen that wharf to accept the weight of the equipment that was being used to actually build this station. But everything had to come that route. And here you see the mule team dragging, not even with wheels, but with a sledge, so just one reel of cable of many. And all of the equipment, all the hardware had to come this way. But you see, some things never change, right? There's 2 guys working and 6 guys watching. It's just the same, never changes. But this was, as you can see, not a very good road. And during the winter, it was so muddy as to be almost impassable. In fact, we have an account of some reporters who tried to visit the station after it was built. And they say that the horses practically disappeared in the mud as they're trying to get out there. So a very difficult situation to get all this stuff, get it in place, get it built, make it work. And here's a closer shot of the powerhouse, the transmitter building. And this is after completion. And you see some significant things here. We have some better photographs, but I'm going to use this one just to show you some things. This is the rotary spark gap before its installation. And you see the flange over on the right, and that's connected to the drive motor that turns this thing. And then within this alloy housing is the actual rotary spark gap. Now, even though it's enclosed in a housing, spark gaps, some of you may know if you've ever tried it, these are enormously noisy. In fact, I was at the Antique Wireless Association Museum decades ago, before they moved into what I consider the new building. And they have an amateur radio rotary spark gap there. It's a low power, it's only 1 kilowatt. So it's a small one compared to these guys. And they have it set up so you can do it. You can turn it on, you can key it. So the curator, who was very kind to open the museum specifically for me, this was during the winter, so it was normally closed. So I was very honored by that. But he showed me, among many wonderful things, this amateur rotary spark gap. And he said, "Would you like to key it?" Of course. Yes, of course I would. So he turns it on, starts to spin. I assume you know generally what these things look like. It's a wheel with sort of spikes on it. Teeth on it would be better. And then the spark jumps across these. But what I don't notice, because he's standing behind me, is he's kind of going a little bit back behind me, and he's putting on ear protection. And so I key the thing, and it's just, it's ear shattering, just that little one. So these were enormously noisy, and they were in their own room called the spark chamber, a cork-lined room, trying to make it as soundproof as possible. But the contemporary literature says that you could hear this thing for an enormous distance, just acoustically. And here is the spark transmitter set up for operation. So here you see the motor, the drive motor here. And here is the alternator that provides the high frequency current, the high voltage current that goes to the spark gap, which is behind the wall here. And of course, there's a backup over here and auxiliary equipment over here. And here's another view, and it just shows what this stuff looked like and what it actually took. And this is just one part of it. This is the actual generating part of the system that actually is generating the spark gap. Upstairs, above that, are the oscillation transformers and the other coils that are required to couple the energy of the spark transmitter into the antenna. And I believe that the wires that we saw, the cable actually that we saw on that sledge being dragged up by the mules up Mesa Road, was used in these helices here to part of the tuning circuit for the transmitter. And there was much more to it than that, even those things, because we're dealing with such high voltages and high powers that you had to blow out the arc on the keying relay. So this is how you can imagine you're putting full voltage across this relay. Can't imagine what it sounded like clacking back and forth. But as the circuit broke, and you've probably been in this situation where you open a circuit and you hear this zap, there's a little arc there. Well, this is no little arc, it's a big one. And so you had to blow that out each time so it would stop conducting. And the same thing with the quench spark gap, to quench the gap in the rotary gap. So here you have these blowers and compressors and all this other amazing stuff. And by the way, the keying was not done at the transmitter site. This was all remote controlled from the central radio office in San Francisco. And the keying information came up wire lines under the Golden Gate and overland up to Bolinas. So the actual keying was done from that central office. Now we're going back a little bit in time because here's where the powerhouse was to be built. So it hasn't been constructed yet, but here's this thing in the foreground. And this is one of the first things that I encountered when I got out to the site in 1972. And it didn't have the angle iron on it, but I just couldn't figure out what it was because it was, it's overgrown. There's all kinds of brush and everything around it, and trying to figure out, what is this, a wall that's fallen over, or what is this thing? Well, I finally realized that what it is the anchor, the physical anchor of the antenna, the multi-wire antenna that was used. Now, here's a magnificent aerial shot of the station. A lot of things to see here. You see, by the way, these plowed lines going over the cliff, for example, into the ocean and over towards the viewpoint here. Those plowed lines are part of the ground system. That's what they plowed to get the copper wire in the ground to get a good grip on the ground, because the ground part was, just as it is today, as important a part of the antenna as the antenna itself. The cables that went over the cliff into the ocean connected to a large copper plate on the base of the ocean, and those that went over to our right in this picture, you can barely see it here, but there's a little bridge there, and that was connected to a plate in that bridge over a little stream. And I really would like to someday be able to do an archaeological dig there to see if we could find that. But of course, this is all on Park Service land, so you can't just show up with your shovel. But it must still be there, or remnants of it. Here is the anchor. So now you get an idea of where it is in relation to the building. And around it, you see this circular structure. That is what we would call today a halo ground. That is part of the ground system. All of the grounding wires attached to that. And it is kept constantly wet with its own water supply. We have a print that shows that. Now here's a ground level view. We're looking at a lot of the stuff that now we've become a little bit familiar with. Here is this box, which is not shown on this photograph. So there was still construction ongoing, and you see all the workers' buildings and material all around here. So now you see this box. This is where the cable came out from those helices into this box, where there was another helix, a tuning helix there. So that is where the antenna wire, the cable, actually exited the building. And here, these poles, and you see that lines are coming down from those poles, and they're connecting to the ground system there. These are the wires that are actually going out from underneath the box to the individual wires of the antenna. And we get a view of how that actually looked, what they actually did there. And here again is that anchor. And you can see now that there are these are not insulators, these are strain relief on the end of the wires. The insulators are a little bit higher up where these horizontal wires are going. And we'll have another picture of that, maybe get a better idea. So you see how that anchor worked. And here's a little bit of a close-up showing a little bit better how those ground wires came down from that second story where all of the high-powered stuff was, and then made contact to the halo ground. And the anchor again. And here's the two poles. So yeah, and there were two on the other side of the building as well, on the western side. Oh, here's the box. Here's the wires. Here's the box here's where the box is going to go. And we say, okay, that's the port in the wall where that cable that we saw from the inside when we were looking at that earlier photograph came out, exited through the wall and into that box. It's right where the box was placed on the wall. So we think it's a fair supposition that that was the exit point. And again, the two poles and the anchor. So looking up here, again, upstairs, and by the way, I just, look, here, this is what they used for safety. A sign that says 13,000 volts, keep away, and a little picket fence. Now, what more do you need than that? I mean, if you stick your hand in there, you get what you deserve. I mean, forget OSHA. You got to know what you're doing and have some common sense here. Give me a break. Anyway, there's what we think is the exit hole for the high voltage, the antenna output. And here we think is the exit for that ground system. This is the switchboard that was used to control everything on the second floor of the powerhouse. And you see over to the left, the coils we were just looking at, little picket fence and everything else. And down below that are the power transformers and all the other equipment. This building does still exist. It is in derelict shape, and there is nothing of this or even of the following technology, sadly, that is left to see. But we still consider it almost hallowed ground. It's clearly the most historic building on the site. And there again, as I was saying, is the coils and the exit. This is where we think that would be the ground exit, and then the other one, the antenna exit there. Now, here we are looking away from the building. The building is behind us, and here's that anchor in the foreground. So this gives you a little better idea of how the antenna was constructed. You see all these wires going up. Up there are where these bars are the actual insulators. And then those wires are going back into that box we saw on the side of the building. So the towers were 300 feet tall. They were in 3 abreast formation. So 3 towers abreast near the building, 3 towers abreast halfway down towards Mesa Road, and another 3 towers abreast just about at Mesa Road, with triadics between them and the wires over the top of those triadics. And the anchor. Here's another little bit better idea. You can get an idea of how the antenna wires sort of launched off into the sky and connected to the triadics across those towers. This also gives you an idea of how barren everything was at the time. This is all fully wooded now. And it also shows you the tennis court that every Marconi station had, the hotel in the middle where the bachelor operators lived. This was not a public hotel, it was for personnel. And then left and right of that are the cottages where the station manager and the chief engineer lived. And these buildings all remain really built to outstanding quality. really well done. Well, here is again a bunch of horses, this time horses pulling stuff. A transmitter station is good, but for a full operation, you need a transmitter station and a receive station. So these folks are bringing the stuff. This time they're using wheeled conveyances and horses up what is now Shoreline Highway, Route 1, up towards the town of Marshall, north of Bolinas and north of where I'm sitting here. So you wanted to have your transmit and receive sites separate because there was so much power coming out of that transmit site that if it was anywhere nearby, it would just overload the receive site. So here they are bringing this stuff up there. And this is what the receive site looked like. This is taken from a boat on Tomales Bay looking east. And you see in the foreground the big building. That again is the hotel for the personnel who lived there. Over here is the powerhouse. Now, that's an interesting thing because at the transmitter site in Bolinas, they didn't have to generate their own power on site. That was the case in many of the Marconi stations around the world. They were so remote that they had to generate their own power on the site and sometimes even had a little railroad that brought the fuel to the powerhouse. So this obviously cost an enormous amount. But Bolinas was close enough to civilization that they could bring in separate lines from two PG&E substations at Alto and Woodacre, and they thought that gave them adequate redundancy. But at the receive site, since the current demands were so much less, they could generate their own power on site, which they did in this building here. And you can see the little steam coming up and the chimney over towards the right part of the building. This is the hotel. And this is one of the two cottages. So same deal as in Bolinas. I have been through all these buildings from attic to basement, and there is not very much in the way of artifacts left there, but you get to see, again, the absolute high quality that was used for the construction of all this stuff. And here on the ridgeline are, again, 300-foot Marconi pattern masts. These are hollow, they're circular. Tubular would be better to say. And the standard pattern, they used them all over the place. And across the top of these was strung the antenna that was aimed directly at Hawaii, because that was the first link across the Pacific. And I actually went up there just to make sure I was right about that with my little sighting compass, just to make sure I knew where they were aligned. And sure enough, nuts on right out to Honolulu. And over here, very, very interesting. There are several of these towers. This is part of the balancing antenna. This is some very interesting technology that actually picked up the signal from Bolinas and phased it against the incoming signal, the weak little incoming signal from Hawaii, so that they could reduce that signal from Bolinas to the smallest possible component. And a friend of mine has actually written a paper about this and how this worked. And this tower is in an area that still exists of housing. And I don't know if I included the picture, it may be later in this, but a friend of mine is now living there. So I went over there and said, look, do you see any artifact of this tower? We know it was here. And he said, well, yeah, we know the artifact. Your car is parked on it. And I looked, and here's right by my front tire is the concrete base and the outline of the angle iron that was eventually torched off when they removed the tower. So here it is looking in the opposite direction and down Tomales Bay. And in fact, over on the right side, that ridge on the right side there, that's where I'm sitting right now. So very, very nice spot to be, I have to say. And here is the hotel under construction. You can see the cottages in the foreground. Spectacularly beautiful spot to be. It's now a conference center. So all these buildings still remain. And here's a closer view of the hotel. And here's a guy taking a selfie, one of the first selfies. And you see another tower of the balancing antenna over by this building. And this is the actual receive building. This is where the antenna came down and connected to the receivers that were tuned to the stations in Hawaii and later in Tokyo and the Orient. We have no photos of the interior of this building, and I have been through it there's some stuff in the basement, but obviously much more modern, nothing historical of historic significance there. So we would really, really love to know exactly what they were using, how the technology actually worked. And much in the same way that the keying at the Bolinas transmitter site was not done at the site, the incoming signals here were not copied in this building. They were transferred to wire lines back down to San Francisco, where they were copied on the inked paper tape that we talked about earlier. Now comes 1920, and the First World War has been concluded. The American Marconi Company has done an excellent job in helping with communications for the United States government. And the United States government says, you know, we really appreciate it. You helped us a lot, and you're done. You're out of here. You've got to sell all your assets. And one of the reasons was that Marconi was negotiating for exclusive rights to these machines. These are Alexanderson alternators. They replaced spark technology, and they are magnificent machines. Ernst Alexanderson of Sweden was an electrical and mechanical genius. These are rotating machines. You can see the motor over on the left, and these machines spun at high RPM, and they spun a disc inside that housing that was notched and had insulators in the notches with very close tolerances to the stator around the outside. So they never had a failure of one of these machines. And if it had to be the tightest mechanical and electrical specifications to make this stuff run. And if at high speed, if it had varied at all, you would have not had an alternator. You would have had shrapnel and guys wounded. And of course, the speed had to be kept exactly correct because that determined the frequency that these things were operating on, which was very low frequency from our point of view. The still remaining one in Varberg, Sweden, in the home country of Ernst Alexanderson, operates on 7.2 kilohertz, 17.2 kilohertz. This one in Bolinas operated at a higher frequency at about 26 kilohertz. And that was because the antenna was a little shorter than they normally wanted, but they were somewhat space restricted. One of our guys has gone to station SAQ, the one remaining alternator station in the world. He has approached the great machine and touched the sacred casting and then backed away reverently and has never washed his hands since. No, I'm sure he did. But these are magnificent. And we even had guys come from that station to visit us as a former Alexanderson station. Now, Marconi was busy trying to get exclusive rights to these machines. And if you were going to be in the business of long distance communication, you had to have Alexanderson alternators. And the US government stepped in and said, no, that's not going to happen. They got a hold of General Electric and said, cancel that contract, end negotiations. Marconi, you're going to have to sell all your assets in your company in the United States to the newly formed Radio Corporation of America. And once they took over the Bolinas sites, they ripped out all of that spark equipment that we saw and replaced it with two Alexanderson alternators, each one capable of 200,000 watts. Now, these were actual CW transmitters. They generated a continuous wave, just like a tube transmitter does these days, or a solid state transmitter. And up here, this is where we saw the switchboard for operating the spark transmitter, so that you maybe orient yourself of where in the building this is. And here's another view, and it shows all the other auxiliary apparatus that it took to actually operate these things, the tuning apparatus, and also everything else. There's books written about it that are fascinating reads if you're into this kind of thing. So when I got there in 1972, here's this plaque on the outside of what we now call Building 1, or the Marconi Company called the Powerhouse. And here's this plaque. They were so proud of having these Alexanderson alternators in the building that they put this plaque on the side of the building. And I read that and I said, man, this is something else. But I returned in 1973, the plaque is gone. And I said, oh my goodness, I hope that this was taken by a collector and not a scrapper. If it was taken by a collector, we've got a chance. If it was taken by a scrapper, it's been melted down by now. So I'm waiting through the 1970s, 1980s, the 2000s, finally get a call from Museum San Jose. And they say, we've got this thing. It's laying in the hallway. People are tripping over it. We think it belongs to you. Can you please come and get this? So there I am, very happy to come and get it. And here's the plaque coming back home into Bolinas. It's in safe storage now. It'll never go back outside. There's some talk about making a reproduction that we might be able to put on the building, but the main thing is we've got it. And a lot of things like that happen where stuff that was once part of the station has gone off to who knows where, and we get this call or somebody comes by and say, yeah, we think maybe this belongs here. And of course, it fills in an important spot in the history of the station. And we're just overjoyed to have this as part of our operation. Well, Marconi, now he's kicked out of the U.S., but he's still a major force in communications, wireless communications. And here's his ship, the Elettra, which he used to not only sail around and have fun, but he also has a large wireless laboratory built on board the ship. So he's busy experimenting. He's busy figuring stuff out and new things. And here he is. Now we have 347 photos of Marconi, and in none of them is he smiling. None of them. And he wanted to be taken as a serious man, so he felt that he could not be smiling. We have one photo where maybe he's got a little bit of a grin, and that's his marriage photo for his new young wife. But other than that, well, he is continuing to do his work, and he's starting to get an inkling that something is afoot, just like Hertz did in his laboratory. Something is afoot here. And we all know the story about how everybody thought in the early days of radio that if you were serious, you had to have gobs of power, extra long wavelengths. The lower the frequency, the better. The longer the wavelength, the better. And short waves, everybody knew, were useless, just like everybody knew that radio waves didn't go over the horizon. But Marconi is starting to get the idea and see that maybe this wasn't true. Now, he had contracts to build coast-to-coast, transoceanic stations, and I believe in Australia and New Zealand, maybe a little off on that, but in one of those two countries. And he could very well have fulfilled that contract, and it would have worked just as he guaranteed it. But he said, no, I tell you what, I will build you the station, but it'll be shortwave. And if it doesn't work, you don't owe me a dime. So he went ahead once again, risked his reputation, his fortune, and his company, and built those stations. And of course, we all know how that works now these days. To us, this is second nature for HF communications. We all know that there's a magic mirror in the sky. Nobody knew that then. And in fact, it took until the 30s for Heaviside to actually characterize it and study it and really understand that there were these various levels. And we now know there's multiple levels and all the rest of it. So this allowed long distance communication with much less power, many circuits instead of just one circuit, a very much of a commercial advantage. So again, he pioneered the use of shortwave and the so-called beam stations, highly directional antennas aimed exactly at your city of interest. And here's one of the first experimental shortwave transmitters, call sign KEL, at Bolinas. The call sign of the Alexanderson alternator was KET. And again, you see the safety precautions. You put up some pipe around this high voltage stuff. And if you're dumb enough to stick your hand in there, you get what you deserve. So this is some of the, and you see 95 meters to us, that's kind of low in the spectrum area. But from the point of view of folks who are down in the basement of the spectrum, this is shortwave. So they're doing this experimentation and it's showing that, yeah, this is a commercially viable enterprise. We can actually use this to make money. So here you see, here's the transmitter site at Bolinas. Now in the shortwave area, here's the powerhouse, the Marconi powerhouse out of the coast. But here's building 2 that has been constructed to house the new shortwave transmitters. Let me just do something. I'm going to turn off sharing here for a minute because I forgot to press a certain button. And I want to do that. I want to share with sound. All right, there we go. Because we got some sound stuff coming up. Okay, should be back. If I'm not, somebody yell at me and let me know. So here's building 2 to house the new shortwave transmitters, and you see the forest of antennas there. Unbelievable. I got to see some of this even much after this photo was taken. But when I first got there, a lot of these antennas were still there, and it was just astounding, really amazing. And here you see a shot taken from one of the 300-foot Marconi poles. And again, no trees, nothing out there. When you come and visit, you'll see what it looks like now. There's a little something here that I want to zoom in on. See that guy there? This is one of the riggers. These guys were fearless and they loved heights. He's zipping up and down the guy wire on a bosun's chair. And these guys, there's so many stories that I've heard and actually met the chief rigger just before he retired. And it was just, to keep this stuff up in the air. It's up to us now. Of course, we don't have we don't have the number of the antennas, but for KPH, there's quite a few. And here we are right at the edge of the coast. And that's the toughest thing for us, is to keep these antennas up and the antenna poles up. And we have an enormous trouble because it's so expensive. This is the one thing we can't do ourselves. We can repair the transmitters, we can repair the receivers, we can do all this other stuff. But we can't repair these antennas without the use of a crane and a skilled crew, which luckily we have the ability to hire these folks on. This is the new receive site. This replaced the site at Marshall when the shortwaves were discovered, and it's the corresponding building to building 2 in Bolinas. Because they needed a new place for the shortwave receivers and enough flat ground around it to construct all the receiving antennas. And they used triple diversity here, space diversity. So there were the A, B, and C antenna fields, and you can see these H-frames on the left and right that brought in the signals from these antennas. So you might have, let's say, stacked rhombics in the A, B, and C antenna field, all aimed at, let's say, Hong Kong. And the receivers upstairs, triple diversity, are automatically listening to all 3 antennas. And as the signal might fade on the antenna in field A, the signal might be coming up in the antenna in field C, and the thing would automatically vote between those. And again, the signals were sent right down to the central radio office in San Francisco. This is how it looked up there when I first got there in 1972. And man, my timing was perfect because this all ended in 1973. But here you see the diversity receivers and the central control console in the middle. The last circuit that still remained was out to Tahiti. They were the last ones to get a satellite station. So that circuit remained. Now, all of these magnificent receivers all went to the scrapyard. We were not there in time to save them. So, okay, what are you going to do? Well, we didn't have anything to show of the point-to-point service. But I got wind that there were 2 of these receivers from the VOA station in Greenville, North Carolina, that they used to receive program material that was going to be rebroadcast on shortwave. And this guy had 2 of them in a warehouse there, and he's paying the monthly bill to store these things. But I got wind of the fact that they were there, and I said, listen, I called him up, and started to say, yeah, okay, we'd be interesting. But, my negotiations were immediately undercut because he could hear me panting over the phone. Yeah, oh man, it's fantastic. So, of course, I wasn't able to get any bargain price. And we had to ship them all the way across the country, which we did. But we now have them. We have 3, actually. I got one from Germany as well. This is another shot upstairs, a little earlier shot. And you can see that one of the things that impressed me most when I was there was that over each receiver is a sign saying the city that it's aimed at. And you can see the one here in the foreground says Sydney, and there's Tokyo and Shanghai and Hong Kong and Guam. And man, I just thought that was unbelievable. And the guys let me listen in on the earphones. You'd hear the marker signal or hear the traffic coming along, and it was just great. And these were independent sideband receivers, so you got 2 circuits per channel. And for some of the lesser used circuits, like the one out to Tahiti, there was one circuit that was used for traffic, and the other was the order wire, so the technicians could talk back and forth. For Tokyo, there'd be 6 or 8 channels, multiple transmitters and receivers, since the traffic level was higher. Well, here is one of the receivers coming in that we got in a crate in my Jeep, and one of our guys, the group that's part of our organization, these folks are just brilliant, just the best transmitter engineers and the best receiver engineers. So you see the components of this thing laid out in the guy's shop. And this is not like any receiver you and I have ever seen. It doesn't work that way. It's just, the technology is just different. But he is brilliant enough to have been able to hook all this stuff together in his shop and restore it step by step. And they were able to reinstall it back at the receive site at Point Reyes. And there it is. It's the only place you're going to see one of these things in person, and certainly the only place you're going to see one that's actually working. And this is in a historically appropriate spot downstairs, because the upstairs room is now converted to a satellite Earth station. But this downstairs spot was where that last receiver for the Tahiti circuit was, and I got to see that in '72. So it's in a historically appropriate spot. You get to see it when you come by to visit. Here is a log that we got. It's actually at the conference center at the Marshall receive site. It's incorrectly labeled as a log for KPH. That's not at all the case. It's the log for a transmitter in Hawaii that is talking to a receiver on that second floor of the building that you just saw in our San Francisco, or let's say Point Reyes receive site. And you see that down at 10:50 p.m. They're continuing to transmit until the signal grays out in San Francisco, and they're on 7462.5. So then they shifted from day frequency to night frequency. And when I visited Building 2, I got to see that. It was almost like a ballet, as these guys would change over from day to night, because this had to just continue. There couldn't be any interruption because time is money. This is the transmitter site upstairs in Bolinas in Building 2A. This is an extension that was built on the west side of Building 2 in 1957 to house yet more transmitters. And here you see the gray RCA transmitters from the 50s. And then behind them are the 1990-91 Henry transmitters that were put in as a replacement for the RCA transmitters. And they were much more efficient, but no soul. Forgive me, but please. So this is how we saw it when we got there, except that it was 100 times more dirty, filthy, and it's just gobs of garbage down the hallway. This place was open to the atmosphere because the windows had fallen out. Even though it was only abandoned for 2 years, we decided we were going to restore one of the Henry transmitters first, because we figured, okay, that's been abandoned for the least amount of time. It's the most modern. We'll be able to deal with this. We opened the door on the back of the transmitter, and here we see standing water from condensation. So, I mean, standing water and 5,000 volts, not a good combination. So we dry and dry and dry, and we clean and clean and clean and dry even some more. And my co-founder, Tom Horsfall, and I say, well, what do you think? Well, I mean, we've done the best we can. So we hit the money button and, oh, yeah, this giant flame shoots out the top. I mean, literally. And we said, well, I guess we have more work to do here. But we sealed up the room. The ambient temperature started to come up, and now we have many of these transmitters restored and working. And we turned our attention to the 1950s RCAs. They had been abandoned in place for 10 years. You could not open those sliding doors. You could not turn the tuning controls because of all the rust and corrosion that had taken place. But we had the luxury of time, which the guys who maintained these transmitters did not, right? What did we just say? Time is money. So let's say that the circuit going out to Hong Kong, the transmitter going out to, and by the way, the DYMO labels are still on all of these transmitters, and it says what city they were speaking out to. So the transmitter to Hong Kong goes off the air. 5 seconds later, the phone rings and it's the station manager. So that circuit down to Hong Kong, it's off the air. And the transmitter technician, of course, says, I know it's off the air. I'd be fixing it if I wasn't talking to you. So they did not have the luxury of taking the time to do full-on repair and maintenance. In fact, when we got there, all the high voltage bypasses that were on all the doors, when you open the door, the thing goes off the air automatically. Those were all bypassed so they could work on the thing live. Well, we eventually got all of these are all now restored, happy transmitters just singing away. And it's a sight to behold, except for these so-called H sets. These are the most complex, the independent sideband transmitters that were the companion to those receivers that we saw upstairs. And you open the cabinet, this is what you see. And all through the set. And it's a very complex electronically and mechanically. You look at this and you say, you just slowly close the door again. I mean, what are you going to do with this? Well, a bunch of guys from Hewlett Packard, including the guy who restored that R3 receiver, joined us and said, okay, we're having fun here. We're doing good projects, but we want something we can sink our teeth into. So I said, okay, you want something you can sink your teeth into? How about restoring one of these H sets? And they took it on. So here's one of the close-up of one of the decks, and this is how it looked once they were done with it. And it's just tons of before and after photos like this. They did a magnificent job, and it took them 3 years and 3,000 man-hours to do it, but they did it. Here's a look at the RF deck and what it looks like from behind. Look at it. It's like it came from the factory. And there are places in here that nobody's ever going to see again once these things are put back in service. For instance, underneath all of the cabling, there's not a cable tie in sight. It's all cable lacing, just like it was from the factory. So if anybody wants to study this technology in the future, they'll see it as it actually was. Now here's the transmitter. Here's the H set. This is the guy, Steve Bizarre, who restored that receiver in his shop that we saw. So they're tuning it up. They finally got it, so it's working. You see the red light on showing that the thing is on the air, and we're tuning it up. Now, these had been converted, like most of the other RCA transmitters. Once the point-to-point ended in 1973, they were converted to Morse code service for APH, so the company could squeeze the last bit of revenue out of the hardware that they had paid for. So here's Steve, and he's tuning the thing up. And here in 2013, on our Night of Night ceremony, here is Cecily Muldoon, who is was the superintendent of the Point Reyes National Seashore at the time. And she is about to push the money button and put this thing on the air. And here you see me leaning in with my uniform and tie on. And I don't know if you can see it, but I can see the thought balloon above my head, and it's saying, please don't let this thing catch on fire. But of course, there was no chance of that because the work that had been done was just so meticulous. So she pressed the button and the thing was on the air. So it's on the KPH 22 megahertz Morse code channel. So when we're working ships in the South Pacific, this is typically the transmitter that they'll be hearing. And you see the meters bouncing with the Morse code. And again, this is going to be one of the only places in the world where you're going to see this transmitter type, and certainly the only place in the world where you're going to see one in operation on its original frequency. So to us, that is a big deal. Well, we figured that we're in the business of crazy ideas. That's what my co-founder, Tom Thorsfall, would always say. And at the competing station down the road, a little bit closer to you guys in Palo Alto, at their transmitting site, they when they went off the air, they used these PW15 transmitters. These are press wireless transmitters. Now, at the night of nights, at supposedly the end of Morse code, where they actually had a ceremony there on July 12th, 1999. It was a lot of people there. It was a very emotional scene. They even let me key some of the last messages. Unbeknownst to me, I was keying one of these transmitters. Anyway, they gave us free reign of the site, and we picked what we thought were two of the best PW15s, and we trucked them up to the Bolinas site, as you see here. And now here's one of them, fully restored, in operation every Saturday on its original frequency with its original KFS call sign. And you see the mercury vapor rectifiers flashing. We retrofit those. They had been replaced by solid state rectifiers. But it's just magnificent to see this thing going. It's once again, only place in the world. So listen, I thank you for your kind attention. Please give me a call or an email if you'd like to come visit. Our website is radiomarine.org with a ton more pictures and information. So anyway, thank you very much for your attention. I really appreciate the opportunity to make this presentation to you.
Test. Thank you, Richard. Great presentation. What we're going to do is open it up to questions here in the room. And then Zoom, if you've got questions, go ahead and put it in the chat. And then we'll make sure we get any of your questions answered. So let's go with questions here in the room.
It's been said that Tesla actually did the early technology as far as broadcasting, and that Marconi was basically able to market that technology. Is there any truth to that?
We don't think there is. There's some extensive writing about that, and I have, in fact, visited Tesla's lab at Shoreham on Long Island and read most of the books. I don't believe that's correct.
Yeah. Okay. Oh, we're going to go to Dave. Then we'll get over to Daryl.
Thanks. So in a visiting venue, then is it necessary to get several people together to come by, or are there enough docents or individuals available for tours of facilities and so on, and what time periods and that sort of thing do you suggest?
Yeah, sorry. Thanks for asking that. I should have mentioned that. Yeah, individuals or even, 2 or 3 folks are invited to come and visit. We're open every Saturday from noon to 4 or 5 p.m. at the receive site at the Point Reyes National Seashore. And there's instructions on our website, or just contact me. You're more than welcome. If it's going to be a group, then we want to make sure that we have everybody in place to give you the A tour. Most folks only go to the receive site. That's the publicly open area. But that's for regular people, not folks like you guys. For you guys, you get to go to the transmitter site if you want to, so we can set up whatever you want. But the thing is open every Saturday, and we have moved some of the KPH transmitters over to amateur channels under the call sign K6 KPH. So for those of you who are Morse code proficient and you wish to sit the circuit at K6 KPH, you'd be more than welcome to do that.
Thank you. Here's another question for you.
You know, we took 2 trips up there from Para, and it was a joy to be at both sites. We actually did both sites in one day. And the question is, I thought I heard you say you guys replaced the mercury vapors with solid state, or are the ones you guys have still mercury?
Yeah, it was the other way around. As these transmitters came to us, the mercury vapor rectifiers had been replaced with solid state, which is exactly what you want to do if you're in charge of keeping these things on the air for 24 hours a day. Of course, that wasn't something that we had to do, so we had the option of reverse engineering, so to speak, and putting back the circuitry and the tubes that allowed us the pleasure of seeing the mercury vapor rectifiers in action. So that's what you'll see when you come up there.
I actually have video of it when I was there. It's awesome. I wish I could have one in my shack. My shack's not big enough, but it's really good. Thank you so much for what you guys do up there. It is really, really awesome. Thank you.
Okay. Henry, nice to see you, Henry.
Hey, this is Henry, W6REK. I've been to the Night of Nights. It's been years, but it was fantastic and one of the most memorable things of any of my radio experience. Are you doing that next month?
Yeah, we'll be doing the Night of Nights. And for those who may be unaware, as I mentioned earlier, the last day of Morse was on July 12th, 1999. And we just said, this can't be let to pass away. And we were fortunate in being able to get the National Park Service to agree with us and allow us to restore the station, so that every year since then, we have commemorated that date and time with what we call Night of Nights. It used to be a public event. We're not able to handle that any longer. So the Night of Nights is actually an on-the-air event. If you want to see the station in operation, the best bet is to be there on a Saturday.
Okay, thanks.
Okay. I think, oh, Shree's got one. Stand by.
So before it became KPH, when it was still PH, Palace Hotel out in San Francisco City, right? Was that, do you know if that, the history of that, was that a transmit and receive station, or do you know any details about that?
Yeah, so here's a man who knows. That's right. I could go on forever, but I'm going to keep it short because I know we're long in time here. But you're exactly right. The station began life at the Palace Hotel in San Francisco using the call sign PH for Palace Hotel. You chose your own call sign back then. We do have a photograph of the interior of the station. Transmitter and receiver were both in a little room together. It was, of course, a Spark transmitter. And that was in 1905. As I mentioned, 1906, bad time in San Francisco. There's a whole story of what happened to the station and where it moved and all the rest of it. Of course, the farther you go back in time, the less information you have, but at least we do have one photograph. It's not a very good photograph, but we've got one showing the interior of PH.
Thank you, Shree. Any other in the room have a question? How about Zoom? Anybody on Zoom yet? Zoom? No questions? All right. Well, once again, as just like before, Richard, very impressive. Your history and the way you just lay this out, it captivates, at least it did me, and it really emphasizes your ability to capture the the nostalgia and then bring it to a little bit of modern time. Thank you so much.
Well, I just want to say, you know, we think we're the luckiest radio squirrels in the world to be able to be involved in this project. And it's also a real honor when groups like yours ask for a presentation, even better, ask for a second presentation. So I'm deeply honored, and I really want to thank you for the invitation.
Well, we've already got our yearly field trip kind of lined up already for the Hornet. So who knows, maybe next year we'll be going up to see this, because I haven't seen it yet. So we'll keep that in mind. Thank you so much.